Another important concept in working with equations in physics is understanding what equations can do for us, how very tidy they are. It gets to that second idea in Greek philosophy that mathematically model things. So equations are mathematical models. If you see them in a physics class, you could be sure we have tested them so much that we have found them to be true universally. Like this one, F equals ma. That's that force is equal to mass times acceleration. Well, how can we use this in a proportion? Well, what we would like to do is realize right away what these things can do for us. For example, if I am not interested in changing the acceleration, in other words, I want to keep acceleration exactly constant, it tells me what I need to do with force and mass. In other words, I'm going to say force is directly proportional to the mass. What does that mean? It means if I'm keeping acceleration constant, and you already know this, if I have twice the mass, how much more force do I need to accelerate that the same way? Well, obviously I need twice the force. 3 times the mass, 3 times the force. Similarly, if I say force is proportional to acceleration, I'm keeping the mass constant. Notice these are all on the numerator. There's nothing in the denominator here. There's no squares or anything here. That's saying if I'm keeping the mass constant, if I double the force, gee, what'll happen to the acceleration? You know, it's going to double. Triple the force, triple the acceleration. A formula that makes me a little sad, makes me a lot sad, is a kinetic energy formula. That's how much energy a moving object has. Kinetic energy equals 1/2 the mass times the square of the velocity. So why does this make me sad? It's because this. Nobody seems to get this. Drivers especially don't seem to get this. So let's put it in a proportion. So we have kinetic energy. We're not worried about this stuff. It's simply proportional, not to the velocity. This is what your gut tells you. Kinetic energy doubles if you double the velocity. But when we do it experimentally, we find out that it is not true. That the kinetic energy is in fact proportional to the square of the velocity. So what happens if I'm going twice as fast to my kinetic energy? Well, 2 squared. So now we have kinetic energy proportional to 2 squared. Well, that's 4. So kinetic energy has 4 times as much. 4 times as much. So a 60-mile-an-hour car crash, how much worse is it than a 30-mile-an-hour car crash? Well, 30 miles versus 60 miles, I have doubled my velocity. 2 squared. So we're saying that a 60-mile-an-hour car crash is 4 times as bad as a 30-mile-an-hour car crash. And you can see right away, this gets substantial. This is very significant. So proportions allow us to take equations and tear them apart and see how these things work out with each other. Another useful equation when we're driving is that the force centripetal, the centripetal force, that's the force going around in a circle, equals mv squared over r. Okay. Again, if you double the speed at which you're going around a curve, there's 4 times as much force trying to pull you off that curve. If your car has twice the mass going around that curve, well, there's no square with that, so you simply have twice the force trying to pull you off that curve. But look down here, the radius of the curve. we can mess with this in ways that can help save our lives. The centripetal force is proportional to 1 over the radius. In other words, it's inversely proportional. As the radius gets bigger, the force on you gets less. Let me explain what I mean. If you're going around a turn, let's look at, if you're going around this turn, this is just a single lane, and this is how you're going. You're staying in the middle of the lane going around that turn. Let's just draw a circle and take an idea of what the radius of that circle is. Great. Well, what if you choose to drive in a somewhat different way? I started driving following trucks and realized they drive in a different way. Again, this is just one lane. We're not crossing into opposite traffic. But if you approach a turn on this side, and as you make the turn, you get close to the inside corner, and then you come back out. Look at what you've done to the radius. You've effectively doubled the radius. So now you have that the centripetal force is proportional to 1 over 2. You've doubled the radius. What did you do to the centripetal force? It's now 1/2 what it was before. Simply by changing your road position, you've cut the centripetal force in half. So while this number gets a lot of people killed, if you pay attention to how these work, they can help you. Number 1, they remind you to keep your velocity low. Number 2, they say you can do other things that make this considerably safer when you're driving. So proportions open up formulas to you and show you the individual relationships in formulas. They're very powerful. They are a wonderful thing to learn because you don't have to solve the problem. You just have to look at how these variables relate to each other. And now you get a deeper insight into all things.